This video, we're just going to kind of combine our knowledge of point slope and slope intercept form and just compare the two equations. Now, to do that, we're going to start off by writing the equation of line that in both forms with the same information given to us. So, let's look at what we have here. We have the point 1, 5, and we have the slope of 3. Let's start off and write our point slope form first. Okay. Well, we know this equation is y minus y1 equals m parentheses x minus x1. Well, we know that our y1 and x1, our y1 and our x1 are given to us in that point. So we have y minus 5 equals 3 parentheses x minus 1. And now let's look at the slope-intercept form. Okay, this equation we know is y equals mx plus b. Well, our slope we know is 3, but we don't know what b is, and we need to know what b is. So there are a couple of ways that we can get b. One way is to plug in these for x and y, and let's do that. So 5 equals 3 parentheses 1 plus b. 3 times 1 is 3, so that gives us 5 equals 3 plus b. And then we're going to subtract 3 from both sides of our equation, and that's going to give us 2 is equal to b. Now that we have this bit of information, we know that our line is y equals 3x plus 2. Is that the only way we can get to the slope-intercept form? No. In fact, given that we knew the point-slope form, we could have just solved for y over here. Which let's go ahead and do that. So if we solve for y, we're going to distribute the 3. And that's going to give us y minus 5 is equal to 3x minus 3. And then we're going to add 5 to both sides. Y equals 3x plus 2. Okay, so this is my point slope. And these two are both my slope-intercept. Okay. Moving to the next example. The difference here being we have 2 points. We don't know what our slope is yet. That is, however, not a problem because we can find our slope using the slope formula. Slope equals y2 minus y1 over x2 minus x1, which is, I need to identify which point's going to be which. I will call the 4, 2, 1, so that's going to be x1, y1. And I will call the 1, 6.2, so that's going to be x2, y2. Okay, so 6 minus 2 divided by 1 minus 4. 6 minus 2 gets us to 4. 1 minus 4 gets us to negative 3, which gives us a slope of negative 4/3. So now we're going to write the point slope form. We have our slope, and even though our formula for point slope says y1 and x1, we really can choose either of these that we want. But just to try to keep consistency, since we named this our x1, y1, we're going to use that. So this will be y minus 2 is equal to negative 4/3 x minus 4. Okay. Now we get to writing the slope-intercept. Well, here's the thing. We're going to do the exact same thing that we did on the previous slide, and that is we have y equals mx plus b. We're going to take our slope and put it in for m, so negative 4/3. And we're going to take our point, either of them, we'll stick with this one, to put in our information here. But here's where the point slope form kind of starts to shine, because while we have calculators, meaning that we can take care of working with fractions fairly quickly, it is an extra layer of things that we have to deal with. So negative 4/3 times 4 is negative 16/3 plus b. And then we would add 16/3 to both sides of the equation. Again, the fact that we have calculators does make this a little bit more straightforward. 2 plus 16/3 is 22/3. So the equation of our line is y equals negative 4/3 x plus 22/3. So we have our slope-intercept form, and we have our point slope form. I think most people would agree that in this situation, our point slope form is easier to work with. But both are still things that we can do. And we're going to move on to our last example, and that is we're going to write this in slope-intercept form. Now, you might be asking, hey, we've already written some of these like this. Yes, we have. I am showing this one for a specific reason, and that is we're going to do it more than one way. So the way that we have done this is we have distributed the negative 5 to give ourselves y minus 6 equals negative 5x minus 5, and then we would add 6 to both sides, and that will give us y equals negative 5x plus 1. Okay. Well, the other way that we can go about it is by using this bit of knowledge. The y-intercept is a point with x coordinate equal to 0. So in other words, this y-intercept we could write as the point 0, comma 1. And that's actually going to tell us what we need to do for our secondary method, which is we're going to let x equal 0. So let x equal 0. What that gives us then is y minus 6 equals negative 5, parentheses, 0 plus 1. Okay, well 0 plus 1 is 1, so this is negative 5 times 1. We still have y minus 6 on the left-hand side. We then add, well, actually let's multiply our negative 5 and our 1 first. So this will be y minus 6 equals negative 5, and then we add 6 to both sides. And what this tells us is that our y is equal to 1, which what that means is that my y-intercept is equal to 1. So my slope-intercept form is y equals negative 5x plus 1, which is something that, yes, we had already found. Okay. These three examples were just meant to highlight the relationship between point slope and slope-intercept form. I hope that everyone is remaining safe, and I will see you in the next